Welcome back. Today's goal of this lecture, today's contents of this video. Today I will see some nice function of complex analysis. Some polynomial function, rational function, we all of us know. In real analysis, this type of function. Similarly, this is in complex analysis, but at first I will just express this function in a complex analysis. Then I will see what is the sine z, cos z, sine hyperbolic z, cos hyperbolic z, e to the power z, etc. in complex plane. Next goal of this lecture, I will see what is the harmonic function and analytic functions in complex analysis. This type of concept actually very important in complex analysis. So, just pay attention in today's video. And here the polynomial defined from complex number to complex number, which is given by pz equal to a0 plus a1z plus a2z square plus adz to the power d. And since z equal to x plus iy, if pz means obviously this is contains x and y. If pz equal to x, then pz equal to actually z plus z bar over 2. That means this is equal to x plus iy plus x minus iy by 2, which is equal to x. I hope my all viewers have understood what is the polynomial function in complex variable. Then I will say what is the rational functions. What is the rational functions? Let pz and qz be polynomials with no common factor, and zq be the set such that z in C such that qz equal to 0. Now define a set gamma which define C omitted zq. Then this is an open subset of the of C which is connected. Now define a rational function which is denoted as Rz from gamma to C such that Rz equal to the rational function equal to pz over qz, where qz be the not equal to 0. In complex analysis, the rational function obviously, since here the all function is complex, so rational means pz over qz. Now I will define what is the complex trigonometric function. In real analysis, complex trigonometric function means cos x sin x, and similarly in complex analysis, this is sin z cos z, which is defined, sin z is defined from complex number to complex number, cos z also defined from complex number to complex number. Similar to before, since cos x equal to e to the power ix plus e to the power minus ix over 2, that means since this is the complex trigonometric function, so this would be cos z. And cos z equal to, similar to before, since this is for real, this is x. Therefore, for complex, this would be z. So this is similar to real, e to the power iz plus e to the power minus iz over 2. And sin z equal to, similar to real, here x would be transferred in z, e to the power iz minus e to the power minus iz over 2i. And we all of us know cos square x plus sin square x equal to 1. So similar to in complex analysis, since here complex, so this would be cos square z plus sin square z equal to 1. Next, I will see what is the hyperbolic trigonometric functions. Hyperbolic trigonometric function is cos hyperbolic, who is defined complex number to complex number. Sine hyperbolic, who is also defined complex number to complex number. Then cos hyperbolic z equal to e to the power z plus e to the power minus z over 2. And sine hyperbolic z equal to e to the power z minus e to the power minus z over 2i. Then cos iz equal to e to the power minus z. Just put the value. Cos iz would be e to the power minus cos iz would be e to the power minus z plus e to the power z over 2. And this is equal to cos hyperbolic z. That means cos iz equal to cos hyperbolic z. Similarly, sin iz equal to e to the power minus z minus e to the power z over 2i. And this is actually equal to minus I sin hyperbolic z. So, cos hyperbolic square z plus minus sine hyperbolic square z equal to 1. Before I have got cos square z plus sine square z equal to 1, but here in hyperbolic cos hyperbolic square z minus sine hyperbolic square z equal to 1. Next, I will see what is the exponential function. E to the power z. We all of us know e to the power z means e to the power x plus iy. And we can write e to the power x times e to the power iy. And e to the power iy means cos y plus I sin y. Then cos y equal to e to the power iy plus e to the power minus iy by 2. And sin y equal to e to the power iy minus e to the power minus iy by 2i. This type of concept actually very important for higher study. Okay. Actually, this type of function for complex analysis always would be used. So, for basic knowledge, I have introduced this function as for review. Then, our next goal of this lecture, this is today's goal of this lecture. What is the harmonic function and what is the analytic function in complex analysis? At first, I will see what is the harmonic function. Definition of harmonic function. Let phi xy be function of two real variable. Then define one region D. Suppose phi x, phi y, phi xx, phi yy and phi are all continuous. Means partial derivative with respect to x and y are satisfied. Then consider the PD. PD such type psi xx xy plus psi yy xy equal to 0. And we all of us know this type of equation is called Laplace equation. And if here I have considered phi be a function of real variable, that means if phi, who is defined as above, be satisfy the Laplace equation on the domain D, and phi satisfy the Laplace equation means phi xx at the point xy plus phi yy at the point xy equal to 0, then phi is called harmonic equation. What is the harmonic equation? I hope my all viewers have understood. Just easy to understand. Better in better way, consider fz equal to uxy plus ivxy. And a real variable u, who is defined from R2 to R, is harmonic if it has continuous second order partial derivative, and since harmonic equation means this satisfy the Laplace equation, that means del 2u del x2 plus del 2u del y2 equal to 0. As for example, u xy equal to x square minus y square. At first, I will prove u xy equal to x square minus y square is a harmonic function. For this, del u del x equal to 2x and del u del y equal to obviously minus 2y. Then del 2u del x2 plus del 2u del y2 equal to 2 minus 2, which is equal to 0. And since u satisfy the Laplace equation, therefore we can tell u is a harmonic equation. And if u is a harmonic function, then v is the harmonic conjugate of u. And how we have to find the harmonic conjugate, this is I will see few minutes later. At first I will see what is the definition of analytic function. When a function be analytic, let's see what is the analytic function. What is definition of analytic function? A function fz is called analytic in a domain D if it is defined and differentiable at all points in this domain. A function is analytic means it is analytic on a domain D means it is differentiable all the points in the domain. If we can say it that f is analytic at a point A in the domain F. F is analytic at this point means f is differentiable at every point in this ball B of A such that absolute value of z minus a less than r, and this is true for some r greater than 0. If f is differentiable at all the point in the domain D, then we can tell the function fz is analytic. That means analytic means it is differentiable every neighborhood of a point. But differentiability means it is differentiable only that point. This is difference of analytic and differentiability. Differentiability means differentiability depends on point. We can tell, as for example, fz equal to absolute value of z square, and we all of us know it is differentiable at z equal to 0 and nowhere else it is differentiable. That means it is differentiable only the point z equal to 0, otherwise this is not differentiable. That means fz equal to mod z square is not analytic, because analytic means this is, if fz equal to mod z square is analytic, then this is differentiable all the point around z equal to 0, all the neighborhood of this point. Okay? And when a function which is analytic everywhere in the complex plane, then we can we talk this type of function as an entire function. Function which are analytic everywhere in the complex plane is called entire function. I hope my all viewers have understood this is okay. Oh well. Now I will see tonight's theorem, the relation between analytic function and harmonic function. Analytic, this always imply harmonic. Also harmonic always imply analytic. And the theorem is, if a function fz equal to uxy plus ivxy is analytic, then we can tell obviously this uxy and vxy be the harmonic function. Second, if uxy is harmonic function for second theorem, then there exists always vxy. Obviously this vxy is the conjugate of uxy. Then fz which is equal to uxy plus ivxy. Obviously this fz always imply analytic. That means analytic imply harmonic and harmonic imply analytic. For first condition, analytic imply harmonic means if a function is analytic at a point means it is differentiable on the open ball. That means since it is differentiable, so this is satisfy the CR equation, and the CR equation is ux equal to vy and vx equal to minus uy. If we partially differentiate above equation with respect to x and other with respect to y, if we partially differentiate with respect to x, then this imply uxx equal to vyx, and this imply uyy equal to minus vxy. And if we add, then that imply uxx plus uyy equal to vyx plus minus vxy. That imply vyx means vx, we can write this is vxy minus vxy, and this is equal to 0. So since uxx plus uyy equal to 0, that means that imply u is a harmonic function. Similarly, v is a harmonic function. And second, if uxy is harmonic function, then there exists a vxy which is harmonic conjugate of uxy, so that fz equal to uxy plus ivxy is an analytic function. For this, now we will see how we have to find the harmonic conjugate. Few minutes ago I have seen this function uxy equal to x square minus y square is harmonic function because del 2u del x2 plus del 2u del y2 equal to 2 minus 2 equal to 0. Now I will see what is the harmonic conjugate of uxy. For this, means harmonic imply the function is analytic. So if uxy is harmonic, then that imply vxy is harmonic conjugate of uxy. Since harmonic imply analytic, that means the function is differentiable at a point A. Analytic means at a point A means it is differentiable whole neighborhood of A. And since the function is differentiable, that means differentiability means it is satisfied all partial derivative be continuous, and it satisfy all CR equation. Satisfy the CR equation. That means del u del x, del u del y, del v del x, del v del y are continuous, and it satisfies CR equation means del u del x equal to del v del y and del u del y equal to minus del v del x. Since it satisfies the CR equation, then it satisfies the CR equation, that means del v del y equal to del u del x, and I have got del u del x equal to 2x. Therefore, vxy equal to 2xy plus 5x. This is the vxy. And by CR equation, minus del v del x equal to del u del y. And minus del v del x means minus 2y minus 5 prime x equal to del u del y means del u del y means minus 2y. Just put the value. This is the minus 2y. That imply 5 prime x equal to 0 and 5 prime x equal to 0 imply 5x equal to constant c. Therefore, since 5x equal to constant c, vxy means 2xy plus c. Now put the value. Uxy means given uxy equal to x square minus y square. That means this is x square minus y square and I times vxy mean 2xy plus c. This is our required analytic function. I hope my all viewers have understood how we have to solve the harmonic conjugate function, and if we can to find the harmonic conjugate function, then easily we can find the analytic function fz equal to uxy plus ivxy. Okay? OL. Now I will see similar type of example. At first I will see uxy, which is equal to x squared cube minus x cube y. At first I will see this is harmonic. Then I will find what is the harmonic conjugate of u. For this, ux equal to y cube minus 3x square y and uy equal to 3xy whole square minus x cube. Notice here ux equal to minus 6xy and uy equal to 6xy. Therefore, uxx plus uyy, which is equal to 6xy minus 6xy. Here minus 6xy, here plus 6x, that means this is equal to 0. Therefore, that imply u is a harmonic function. Since u is a harmonic function, then we have to find the harmonic conjugate of u. To find the harmonic conjugate, since u is a harmonic function, therefore it is analytic, so it satisfies the Cauchy-Riemann equation. That means vy equal to ux and vy equal to minus uy. Then since vy equal to ux, therefore vy equal to ux means y cube minus 3x square y. This is means y cube minus 3x square y. Therefore, that implies similar to before, v equal to integration y cube minus 3x square y dy. And that imply y to the power 4 over 4 minus 3x square y square over 2 plus 5x. Now, differentiate with respect to, sorry, here vx equal to minus uy. Since vx equal to minus uy, so differentiate this v with respect to x. Then that imply vx equal to this would be 0 minus 3 xy plus 5 prime x. And since Vx equal to minus uy, notice I have got uy equal to 3xy square minus x cube. Therefore, since this is equal to minus uy, therefore this is equal to minus 3xy square plus x cube. And from this equation, this imply 5 prime x equal to x cube. Since 5 prime x equal to x cube, that imply 5x equal to x to the power 4 over 4 plus c. This is the 5x. Now put the value of 5x here. Vxy equal to y to the power 4 over 4 minus 3x square y square over 2, and 5x means x to the power 4 over 4 plus c. This is the Vxy, and this is a harmonic conjugate on U. I hope my all viewers have understood this question easily. Okay? Well, I will stop here. In my next video, I will discuss what is the relation of power series, Taylor series with the analytic function. See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.